Hi, good evening students. So in the previous the previous video, we discussed the vectors introduction. So you can watch the topics what we discussed in the previous video. So slowly I am scrolling this, you please watch, and then continuation I will explain today. So these are the topics we discussed: scalar vector definitions, and then representation of a vector is discussed, and types of vectors, polar vectors and axial vectors, examples, and then some types like vectors are parallel vectors, unlike vectors are anti-parallel vectors, equal vectors, then negative vector, unit vector, null vector, and then position vector. So these are the topics we discussed in the previous video. See, these are the last video or last class topics. Say position vector. Position vector is discussed in the last class, and also directions, and then estimation of direction. How to estimate the direction, that also discussed in the previous class. And lastly, geometrical method, addition of vectors. Addition of vectors discussed in the previous class. So this is the last topic in the previous video, addition of vectors. Up to this stage we discussed in the previous video. Now I am going to explain the laws of vector addition. Laws of vector addition. Usually in the previous video we discussed scalar definition as well as vector definition. The first topic is laws of vector addition. Laws of vector addition. Usually the definition for vector, we can say a physical quantity which has both magnitude and direction is called a vector. But that magnitude and direction is not sufficient to laws of vector addition. We have three laws here, but these three laws are also important. If any physical quantity wants to say as a vector, so along with the direction and magnitude, that physical quantity must obey the laws of vector addition. I told already in the previous classes to you, speed of light or velocity of light as well as electric current, these two quantities, they have both magnitude and direction. Even though they have both magnitude and direction, they are not treated as a vectors because they are not satisfy the laws of vector addition. Laws of vector addition. So any physical quantity, it is compulsory along with the magnitude and direction, a vector physical quantity must satisfies the laws of vector addition. In that first one is vector addition is commutative or commutative property. Commutative law or commutative property. So you may heard already these words in your lower classes. Commutative law. Let P bar and Q bar, are two vectors. Q bar and P bar are two vectors. Then we can write commutative law is P bar plus Q bar is equal to Q bar plus P bar. This is called a commutative law. So vector addition must obey the commutative law. Let us take a graphical method or geometrical method also. Let us take here. So this is P bar. Let us assume a vector P bar, and second vector, this is a Q bar. P bar and Q bar. Now we can shift the Q bar to here. This also explained already to you in the last video. When a vector is shifted parallelly in the same plane, when a vector is shifted parallelly in the same plane, nature of vector does not change. And in the above, we discussed addition of vectors. When first vector is drawn as it is, tail of the second vector should be kept on the head of the first vector. Then by joining the tail of the first vector to the head of the second vector, this line gives the resultant of the two vectors, sum of the two vectors. So P bar plus Q bar, let us give the names here. OA is first vector, OB is second vector, and here C. OC gives their sum or addition, P bar plus Q bar. This is one. And now, so P bar also, if we can draw a parallel line to P bar, that is BC. Okay, students, we continue. So this is the commutative law. Commutative law, either we can take P bar as first vector, Q bar second vector, OC gives the P bar plus Q bar, or OB, Q bar is taken as first vector, and BC that is P bar. P bar is taken as second vector. So again Q bar plus P bar. Q bar plus P bar also equal to OC bar. So in the diagram, so OC bar is equal to P bar plus Q bar in both the cases R. So OC bar can also gives Q bar plus P bar in the second case. So this is a laws of vector addition. First one, commutative law, and second one is associative. Second one is associative law. Same, let P bar, comma Q bar and R bar are taken as three vectors. Then associative law can be written as P bar plus Q bar is treated as one vector and R bar is a second vector, is equal to P bar is only considered as first vector plus Q bar plus R bar is taken as second vector, similar to commutative property. Actually here we are taking three vectors, P bar, Q bar and R bar, but we can divide P bar plus Q bar first vector plus R bar is equal to P bar first vector plus Q bar plus R bar is second vector. That is similar to commutative property. So this also we can explain in geometrical method. Also, let us take here P bar is one vector, P bar, and here you can consider this is Q bar is second vector, and R bar is third vector, P bar, Q bar, R bar. First, what is there in that equation? P bar plus Q bar. See, let us see here this dotted line gives P bar plus Q bar, dotted line, and then now plus R bar. So P bar plus Q bar is taken as first vector, R bar is second vector, so that this dotted line gives the let us take here OA is first vector, AB second vector, BC third vector. Then OC bar is equal to in the diagram. So P bar plus Q bar plus R bar. P bar plus Q bar plus R bar. Observe the diagram carefully. And in the second diagram, the P bar we can draw as it is, and Q bar, then R bar. P bar and it is Q bar, then it is R bar. Now, first we can write Q bar one vector, R bar is another vector. So here dotted line, observe the dotted line here. This dotted line gives q bar plus r bar. Q bar plus r bar. Dotted line gives q bar plus r bar. Next, P bar is one vector in the second diagram. P bar is one vector. Q bar plus R bar is taken as second vector. So that we can draw here this line. Say as it is O, here A, B and C. In the second diagram, OC bar is equal to P bar plus Q bar plus R bar. This is. See, in both the cases, OC bar gives P bar plus Q bar one vector plus R bar second vector in the first diagram. In the second diagram, OC bar gives P bar is one vector plus Q bar plus R bar is second vector. So, like this, we can explain the associative law also. Next, third one. Third one is distributive law. Third one, distributive law. Here, let k, k1 and k2 are three constants. Three constants. Constants and three constants and P bar, Q bar are two vectors. Then can write. So the distributive law can be written as distributive law. See here, k into P bar plus Q bar can be written as k into P bar plus k into Q bar. This is one. And second one can write it as P bar into K1 plus K2 can be written as K1 into P bar plus K2 into P bar. This is the distributive law, commutative property and distributive law. So let K and K, K1 and K2 are K1, K2 are the three constants and P bar, Q bar are two vectors. Then K into P bar plus Q bar can be written as K into P bar plus K into Q bar. And P bar into K1 plus K2 is equal to K1 P bar plus K2 P bar. So this law is called distributive law. So any vector physical quantity, to say a physical quantity as a vector, it must have the magnitude and direction along with magnitude and direction. That physical quantity must obey the three laws of vector addition. Three laws of vector addition. Next, I am going to explain most important question. Parallelogram law of vectors. Parallelogram law of vectors. One of the most important question. Parallelogram. First, can write down the statement here. First, statement of the parallelogram law of vectors. When two vectors are represented, with two adjacent sides, of a parallelogram, two adjacent sides. When two vectors are represented with two adjacent sides of a parallelogram taken in order, both in magnitude and direction. So parallelogram not taken in order. Say here, two vectors are represented with two adjacent sides of a parallelogram, both in magnitude and direction. Both in magnitude and direction. Both in magnitude and direction. Then the diagonal passing through the same point. Diagonal of the parallelogram passing through the same point gives their resultant both in magnitude and direction. Both in magnitude and direction. See, listen students, read carefully the statement of parallelogram law of vectors addition. After completion of the discussion, proof and everything, then you will get clarity on this statement. Nothing to worry immediately now itself. So read once again and listen carefully until the completion of this question. Then at finally, definitely you will get clarity on this statement. Read once again. When two vectors are represented with two adjacent sides of a parallelogram, both in magnitude and direction, then the diagonal passing through the same point gives their resultant both in magnitude and direction. This is the statement. And according to the statement, see, proof. Let P bar and Q bar are two vectors. P bar and Q bar are two vectors. Then two vectors and angle between them is theta. Let us assume that P bar and Q bar are two vectors and theta be the angle between the two vectors. That is, say here let us take P bar is one vector and Q bar is a second vector. Now we want to add these two vectors or sum of these two vectors. Addition is nothing but addition of two vectors. Is nothing but sum of the two vectors. So this sum angle between these two vectors is taken as theta. According to the statement, let us now draw P vector as it is. So P bar as it is, and Q bar also we can draw Q bar also as it is. Q bar. According to the statement, P bar and Q bar are now the two adjacent sides of a parallelogram. Then the diagonal passing through the same point. Let us take here O is a point. The two vectors P bar and Q bar are simultaneously acting at the same point. Now, the diagonal passing through the same point. If we draw a diagonal passing through the same point, diagonal of parallelogram, let us take OP, P bar is taken as OA and Q bar is taken as OB, then it is C. So first of all, you can complete the parallelogram. Here. This is OABC is a parallelogram. Now diagonal passing through the same point, that is OC bar. So OA is equal to P bar, comma OB is equal to Q bar. Q bar are the two vectors. Then OC is equal to R bar, resultant, gives their resultant. Now resultant vector has both magnitude and direction. So to know the magnitude of this R bar, this is R bar. To know the magnitude of R bar, here theta is the angle between P bar and Q bar. To know the magnitude, now we want to calculate both magnitude as well as direction. Magnitude and direction. First of all, magnitude of resultant. Magnitude of resultant, that is modulus of R bar. Magnitude of resultant. To know the magnitude of resultant, first of all, we should extend OA line. And a perpendicular is drawn. Onto this OA line from C. To know the magnitude and direction, magnitude of resultant of P bar and Q bar, we should extend OA line and a perpendicular should be drawn from C onto this OA line, and let us take it is D, a point this perpendicular intersects the extended line OA at D. So it is a 90 degrees perpendicular. Here theta at A, that is in parallelogram. Angle, observe the diagram, BOA is equal to angle CAD is equal to theta. Same angle at O as well as at A, angle is equal to theta. Now extended sides, we don't know the length of AD as well as length of CD. To know the length of AD as well as CD, let us take a small triangle from triangle ACD. First of all, you can write sin theta. Sin theta is equal to opposite side by hypotenuse. Here hypotenuse AC also equal to Q bar. So sin theta is equal to CD divided by AC. Magnitudes. So that implies CD is equal to AC sin theta. AC is nothing but magnitude of Q bar, or that implies CD is equal to Q sin theta. Let us assume it is equation number 1. CD is equal to Q sin theta. That is next, cos theta from the same triangle. Cos theta is equal to cos theta adjacent side AD divided by AC, or AD is equal to AC cos theta. AC is Q, so that AD is equal to Q cos theta. Let us assume that it is equation 2. CD is equal to Q sin theta, equation 1, and AD is equal to Q cos theta, equation 2. Then in another triangle, observe the diagram here, parallelogram. In the another triangle OCD, now from another triangle OCD triangle. So OC square according to Pythagoras theorem. Observe the diagram. OCD triangle, right angle triangle, according to Pythagoras theorem, OC square is equal to OD square plus CD square. OC square is equal to OC square is equal to OD square plus CD square. But OD can be written as OA plus AD. OD can be written as OA plus AD. That implies OD is equal to OA is P, magnitude of P bar, plus AD is Q cos theta. AD is Q cos theta from equation 2. Q cos theta from equation 2. And CD is equal to from equation 1 Q sin theta. So therefore OC square is equal to, in the place of OD, now we can write OA plus AD, OA plus AD whole square plus CD square. From equations 1 and 2, from equations 1 and 2, we can write OC square is equal to, so P plus Q cos theta whole square plus CD is equal to Q sin theta whole square. But OC is equal to magnitude of R bar, that is equal to R. So therefore R square is equal to A plus B whole square expansion. P plus Q cos theta square is A plus B whole square expansion. So that is A square, that is P square plus B square, Q square cos square theta plus 2AB, 2PQ cos theta plus Q square sin square theta. And that implies R square is equal to P square plus 2PQ cos theta plus, so P square, say Q square into sin square theta plus cos square theta. Sin square theta plus cos square theta. We know that sin square theta plus cos square theta is equal to 1. We know that sin square theta plus cos square theta is equal to 1. So therefore R square is equal to P square plus 2PQ cos theta plus Q square. Or magnitude of resultant, R can be written as square root of P square plus 2PQ cos theta plus Q square. So this is the magnitude of resultant of P bar and Q bar. Magnitude of resultant of P bar and Q bar. Direction of resultant of the two vectors. So to know the direction, in the above diagram, let us take say in triangle OCD in the above diagram, let us assume that alpha is the angle between P bar and resultant of two vectors. Let us assume that let alpha be the angle made by R bar, with P bar, then this angle alpha gives the direction of resultant. So from triangle OCD, tan alpha is equal to, so CD divided by OD, or that is equal to CD divided by OA plus AD. So from equations 1 and 2, from equations 1 and 2, from equations 1 and 2, we can write tan alpha is equal to CD is Q sin theta divided by OA is P plus AD is Q cos theta. So tan alpha is equal to Q sin theta divided by P plus Q cos theta. So that implies alpha is equal to tan inverse of Q sin theta divided by P plus Q cos theta. P plus Q cos theta. This is the, so this alpha gives the direction of resultant vector.